Welcome to Nostrum High Performance. My name is Bruno Silva and I'm the CFD engineer here at Nostrum. I work on the spray development on the CFD, and I am the responsible for the spray characterization on the experimental part as well. Today we're going to be talking about the assets available in-house to do the spray characterization both for PFI and DI injectors. Before we start talking about the equipment, let's talk about what is a spray pattern and why is it important. The spray pattern is the footprint of your spray. It provides the information of the spray targeting, its geometrical data, and also the mass distribution. And it's important because it's application specific. This means that the spray pattern is specific for each application, and it will result in the better interaction between the fuel injected and the airflow in the intake ports for the PFI injector or inside the combustion chamber for a DI injector. This will result in a better fuel mixture formation, higher quality of combustion, and higher efficiencies. The spray pattern can change between two different generations of the same engine, as the example shown now, in which you can see a Gen 1 and Gen 2 EcoBoost injector, but it will also change between two very different engines. For example, the EcoBoost and a Nissan injector. To show the example of two different spray patterns, here we have two spray patterns for two different generations of an EcoBoost engine. We can see that they have different shapes, but also the orientation of the spray in relation to the electrical connector. Here at Nostrum, we use our arc flash imaging system. This machine was custom made for Nostrum, and the way it works is that there is a control module that will control the injector driver, the arc flash unit, and the camera. As the injector is firing, the arc flash will create a burst of light with a high intensity and short duration that will illuminate the spray, and the camera will capture the picture. With the pictures captured, we can measure the direction of each plume. We can also measure the angle of the spray, and we also have another feature in this equipment that we can take the pictures of the spray at different time intervals, so we can follow the evolution of the spray, which is also called display penetration. Since we're relying on the image captured by the camera, we cannot see what's behind the spray, or we cannot have the idea of the mass distribution. So for that reason, we need to use our Hexcel patternators to obtain the mass distribution of the spray and also validate the results that we obtain with the imaging. This is our Hexcel patternator. It's capable to measure the mass distribution of the spray over a cross-section of it, and it works by collecting the droplets over 253 cells. They are arranged in a hexagonal, that's why it's called a Hexcel, and each cell is precision machined. It has its own transducer, and each one is measured independently and individually from the rest. With the liquid collected at each cell, the software then is capable to reconstruct the 2D representation of the pattern and calculates its geometrical information, but it's also capable to identify each plume and calculate the direction of each and also the percentage of mass in each plume. The testing methodology for this equipment follows the SAE J2715 standard for spray characterization, and we are capable to run injectors from 3 bar to 345 bar, which covers the range used today for PFI and DI injectors. Another curiosity for this equipment is that it is available to only a few companies, and we are very proud to be one of them. With both of this equipment available in-house, we can quickly baseline a stock injector during the initial stages of product development, and then after we get the prototypes, we can easily validate our computer models, but also make a direct comparison between our product and the stock product. For more information, please visit us at nostrumshop.com.